introduction. Good morning, all.
Good morning.
This is the 11th time that this conference is happening, and I have the privilege and honor of being a returning guest. So I've been here numerous times, and I've been over Malaysia. I've been to Borneo, to Sarawak, into the jungle. I've been to Cameron Highlands, to Penang, Georgetown, Langkawi. Last year also went to Terengganu and also to Redang and Virgin Islands. So if Eric's prediction about testing getting extinct will become true, then I have a plan of becoming a tourist guide here in Malaysia. All right. Now I had thanks Eric for a good introduction to my speech. I have a good segue to my talk. Eric described a lot about the state of the union, so to speak, with respect to testing where we are, and he described what we're doing today and what we should be tomorrow. Now I'm going to dive into the tomorrow part, and my point is that your journey tomorrow starts today. And I think some of the practices that Eric mentioned are already happening. I'm going to show some examples of that. So I'm going to start first by setting the scene of describing basically how IT is transforming. Obviously Eric already covered that, so I'm not going to spend a lot of time on that. I'm going to describe the concept of analytics and testing, and how it relates to testing. Then I'm going to go into the concept of cognitive QA. This is a concept that has been developed by some of my colleagues, which is basically a combination of traditional metrics together with automation, together with artificial intelligence packaged together as what we call cognitive QA. I'm going to show an example of that, an example of implementation at a customer, and also an example of some of the tools that can be used just to set the scene and make sure that we all understand, have a common understanding of what analytics really means. And at the end, I'm going to close by addressing some of the people cultural aspects. We're focusing a lot on true analytics, quite an advanced concept. And my point is also that we need to change the culture and address the people issues that will address that will emerge when you move into cognitive QA. All right. Let me just start by a more basic slide. Now, some of you might, if you return to this conference, you might have seen this slide in the past. I'm going to start with my testing process. This is a testing conference. This is my testing process. Very simplified, yeah? Testing is in the center of the world. What happens in testing? You have a software version, a software application on the test, coming into testing, version X or 1, right? What happens is, a lot of effort, a lot of money, a lot of resources, planning, execution, learning, replanning, regression system, etc. What comes out? Application on the test, version X or 1. The process of testing itself doesn't change the product. Am I right? We are not hacking the binaries and changing the executables of testing. Someone else is doing that. So if you look at it on the surface, it seems like a very cool process, doesn't it? Putting something in a production line, putting a lot of effort, and out of the other end of the production line, the same thing's coming out. So I must be getting something else. What is it? What am I getting? What additional value am I getting out by performing the test activity? Any views on that? Data, information, excellent. Now, my point is that the main value we're providing in testing is information. If you're doing a good job, you're providing valuable information to the stakeholders in the company. Now, imagine some of the information sources that you can subscribe to. Your favorite media, for example. What makes you subscribe to that media? Just think about it. What makes you pay for a certain service providing information? Typically, you want to have accurate information, specific in the context that you work in, that you use it. You want information to be attractive to you, relevant. You want it to be timely, getting the right information at the right time. Now, this is one of the main missions in testing. So we all information providers. And if we do a job correctly, our stakeholders would want to subscribe to our information. Yeah. Now, this also leads to some interesting questions that I see in many organizations. Is it the responsibility of the testers to put in the quality of the products? What do you think? I think so. You're not changing the product, you're providing information, so how come it's your responsibility to put in the quality?
This is for the developer, right? So the developer need to steal the quality and you as tester to verify that.
You need to convince someone else to put in the quality. Huh? So my point is, sometimes we take it as a mission, put it on our shoulders that we're the ambassadors of quality. In my view, yes, we have an opinion, we can come with information, but it is someone else's task. Yeah? In my view, this is like in the court of law. Typically, you ask a tester, the software is guilty until proven innocent. Yeah? If you have a project manager, he has the opposite view. Yeah? So in the court of law, you take both cases, take to the product owner, and present both cases, and let them make a decision. So in my view, the best thing you can do in testing is to make sure you have solid information, you have a good basis for your decision makers to make a decision. Good decision. All right. I think Eric just mentioned this morning about the pace of change we're going through in the industry. In the 70s, you've heard about there's Moore's law being coined back in the 70s, that the number of transistors is doubling every second year. And this has been the case each and every year since then. We also hear about data exploding. I've recently read by Gartner research that 90% of the data we have today have been created in the past 2 years. 90%. And this pattern keeps repeating. So data is exploding. And the pace of change is unprecedented. Now what is happening, we see a shift that is transforming IT from what we call core IT to fluid IT. What do I mean by that? If you think about just 5, 10, 15 years back, when you wanted to do a bank transaction, or your travel, tickets for a concert, rent a video, you need to walk down to the store, meet the clerk, and who will process the thing for you. Do the things in the systems, and then hand you the goods or the products or the service, the tickets. What is gradually happening is that we're bypassing that. We're going behind the clerk directly into the systems. So we're opening that channel directly for the end users. This is what is known as fluid IT. So most companies are living in a world where they have two types of systems. One, which is characterized by predictability, resilience, robustness, stability. This is basically where you need to handle your master data, your core business processes. This is characterized by low level of change. You want your system to be very robust and resilient. On the other hand, you have your customer-facing applications. We have a high level of agility. This is where we have an unprecedented speed of change. This is where we're going agile, we're going DevOps. We probably also discussed this morning. Now, my point is, as testers, most of us, we're coming from this world, the core IT world, where we have very well-defined process of how to handle testing in a very core IT-based world. But we're gradually moving from core IT to fluid IT. And guess what? Money in most organizations are shifting from the left towards the right, from core IT to fluid IT. Typically, companies want to save the money here in order to channel it over to fluid IT to invest in the new digital customer-facing, customer-centric applications. The ones that you're using, for example, communicating with your bank through your mobiles, your IoT devices, etc. This has also been characterized as basically a shift from the sort of system of record system of differentiation to system of innovation, where you have exploration, agility over here, while you have the robustness, stability on the left side, as mentioned before. Now you can also think about it as number of wheels or cogs that you have, for example, in a clock or in a system, where you know that, for example, on the left side, your wheel will be moving very slow, the one in the middle slightly faster, the one on the right very fast. The main challenge we're facing as testers is that this wheel is turning very, very fast, and we need to cope with that. So the speed of change and the demand for doing adequate testing while keeping the quality intact is becoming higher and higher, which is also mentioned by Eric. Complexity is increasing. Now, this is all about creating value streams. I borrowed this analogy from Ken Beck. What do I mean by that? Imagine we have this bucket, and I want to transpose some water from this end of the room to the other end of the room. What do I need to do? You need to carry the bucket to the side, and if you know the other side they demand more water, I need to have more buckets, yeah? Now, I can also create bigger buckets and have more people carrying all the water to the other end of the room, yeah? What's more efficient is you can create a pipeline. So the whole idea, when you look about fluid activity, is creating a continuous stream of software getting developed, delivered to the customer. Probably you have heard about Rockefeller. You know, Americans here will probably know Rockefeller. You know, he was known as the wealthiest man in history, in modern history. He based his wealth on oil, and it became, you know, pretty much a monopoly. He was owning about 90% of the American market, you know, back in the 19th century. Now, the real creation of wealth happened when he realized that back then they didn't have a lot of trucks, so he was transporting the oil based on railways, on trains. What he created basically came with the idea of creating pipelines with the oil across the U.S. This is how we created the wealth, became the wealthiest man in modern history. My point is, a lot of companies trying to create the same kind of concept, having this steady stream of continuous software being developed to the end users. Obviously, the key challenges that we're facing is first of all, increasing speed and complexity. As already mentioned by Eric, you know, the chain is never stronger than the weakest links, and of course, if you have a weak link in the chain of interconnected systems, you know it will break. There's a high likelihood it will break, and it will break where it will hurt. You have to probably see the domino effect, where one system will bring down all the other systems. And what we see today is that we still have insufficient automation to make sure we can support that value stream, continuous delivery, continuous flow of software. Now, each year Capgemini does a work quality report, and each year we ask the question, what's the level of automation that has been achieved by different companies? And we've seen some advances, but still the average is less than 20%. So nowadays, even though that we have this high-paced development, go to agile levels, the average automation level still is below 20%. We also see, of course, the challenge of being able to cope with the test data and environments, and being able to have a time focus. How do we know whether we are creating the right software that meets the customer demands? How do we make sure that we're capturing the right requirements, that we have the right strategy to meet those challenges? This is where analytics comes into the picture. Now, I think Eric had the definition of analytics. Actually, I have the same definition. I'm going to elaborate a bit on this. Let me show an example of an analytics tool. By the way, how many of you are using analytics today? Raise your hand if you can. Okay, we have one. Have you seen an analytics tool, a web analytics tool, for example? Raise your hand. How many have seen it? Okay. Let me show you one. Let me show you one. I mean, I told you I'm gonna show a few examples, so let me show you one. This is a simple web analytics tool. By the way, I don't have any connection to this company, and I'm not promoting specifically any special software here. I'm just showing an example. This is a dummy website. What I'm seeing here is a real-life application showing basically how many visitors are coming into the website. I've selected a number of visitors in August. So I can see, for example, where the different users are logging in from. I know, for example, that about 24% of the users in August were from the US. I had about, let's see, about 10% from China, 6.6 from India, let me see here, Germany about 5%. Let me see if I can, Malaysia, here it is. Oh. Need to zoom out. Okay, the users coming from Malaysia. If you look at what it will also show you is basically how many, what is the pattern of when they have been logged on, over time, how many visits we had over time. Software, look at the kind of software that they've been using. For example, I see that of about 1,000 visits, about 60% were using Chrome, about 10% were using Firefox, and I see only a few using, for example, Microsoft Edge and Internet Explorer. I see also different version of combination of, for example, mobile devices, Android, 6, 7, 8. It's a bit surprising. I would maybe imagine that it would be higher, but that's not the case. Well, let me ask you a question. How can I use this information in my testing? Anyone?
What are the platforms to test on?
Exactly. That's the obvious one. First of all, based on this, I know that if I cover these two, pretty much I've covered 70% of all the platforms being used by my end users. You can also look at the demographics that we mentioned before. Looking, for example, at where the different users are coming from, what countries. This would give insight into maybe the existing requirements, but also new requirements. For example, if I know that I have a number of new users coming into my systems, I might be able to create a certain language, for example, to support certain language in my application. Let me show another example. Behavior. Here I can see how many, what pages customers have visited. So for example, this is the main page, so of course it has a high number of visitors, about 90% started here. But what is this? Bounce rate. Now bounce rate is basically where the total percentage of the people who left immediately after reaching this page. What does it mean? It might indicate that I have an issue there. It might be a website or a page where people are getting into a deadlock, we're not able to proceed, and they're just abandoning the website. That might be an indication for me testing to look, maybe dig into that, identify whether we have some issues there in this website. So my point is, we can use this based on real-life data in order to calibrate our test strategy. Eric mentioned that creating test strategies, and obviously you create the risk analysis based on your guesses, past experience, etc. But this will give you an additional dimension. This will give you the ability to basically tweak it a bit based on the knowledge you're getting directly from your customers. This can also be used to tailor the test automation strategy. Identify where you need to put your focus, what kind of test you need to focus, what kind of test you need to automate first. As mentioned before, automation is becoming a necessity. As I see, it's no longer a nice to have thing, but it's becoming a necessity in software development. And of course, you can use analytics to drive your strategy with respect to automation. I have a bug. Microsoft stopped working, so let me just restart that.
Yeah.
Okay, so let's continue. So what is the definition of analytics? I think I've chosen the same definition used by Eric. This is the simple one I found in Wikipedia. Basically, analytics is the process of discovery, interpretation, and communication of meaningful patterns in data. We've been using analytics for many years. I mean, the idea of analyzing data and based on data, making decisions has been around for many years, for centuries, basically. And I think I'm coming from the Nordics because we have a recorded experiment with them going back to the Swedish government, going back to 1749, where the Swedish government tried to get demographics of people, trying to record demographics of people in order to identify where how to put the strategy for the defense. Florence Nightingale, back in 1850, created first records of trying to correlate mortality numbers with different living conditions across different locations. Now, all of these, of course, scientists had maybe an instinct, an idea about that something is wrong, but needed, of course, the data and the data correlation to support their theory. I think what is the main difference today is that we have an unprecedented capability of processing large quantity of data to extract, together with machine learning, to extract this meaningful and correlation out of my data, out of your data. I think back to the mission of testing, the value of analytics resides in converting the raw data into insight for making better decisions. Now, you've probably been wondering about this picture of the fox. Yeah? Can you see the fox, by the way? Can you see a second fox? A much bigger one. How many of you can see a second fox? There's a very big one. Can you see it? Let me help you. Think, this is the face. These are the ears and the tail, yeah? So my idea is sometimes when you have all the data in the world just in front of you, but yet you're not able to correlate and see the patterns. This is the power of analytics. Analytics can help you find the correlations between the data. One obvious place to start is listening to your customer. Now, you probably, maybe in school when you're young, played a game of Chinese whispers. Have you heard about that? Basically, I'll whisper something in the ears of Nastura, and she do the same, it will go on, and at the end, I'll probably not recognize what I said to Nastura. Now, the thing is, in software development and testing, we've been doing Chinese whispers for quite a long time. In the sense that, customized whispering in the ears of sales and marketing, what their desires are, and then, they're whispering into the ears of the lead architect, who is whispering in the ear of the designer, who's whispering in the ear of the developer, who is then passing on to test and so forth. And for each phase, the message gets diluted. Sometimes we forget, what is the customer really saying about them? What is the customer opinion about them? Now, there are several tools out there that enable us to go directly tap into the source. Instead of guessing, most approaches in the past have been about inviting a number of focus groups into the company and then asking them questions, creating surveys, etc. Now, I can go directly to the source, get it from the customers. I can go to the social media, for example, listening to what they say about my products, any issues they experience, and pass it back to my development teams, my testing teams. So how do you work with analytics and testing? Well, we've already covered some of it. First of all is gather information about your products. Now, I've once heard the term, I think it was Paul Girard who used the term products intelligence. Yeah? I think most of us can claim to be agents in the PIA, not the CIA, but the PIA, the Product Intelligence Agency. What we're doing in testing, as mentioned back to information, is that we're spying to what users are doing, we're spying to what developers are doing, and we're trying to extract that information and pass it on to the decision makers. So we can identify user behaviors, the obvious ones, or even the hidden ones. Sometimes, some certain behaviors might indicate certain issues that we can face, or certain requirements, latent needs that we can address in a future release. As mentioned before, we can look at bounce rates to identify potential problems. Why are the customers, for example, leaving our websites? Why are they leaving our mobile devices when they're, for example, going to a certain transaction? We can also use for different patterns. We can use all of those as an additional layer to our traditional metrics. Some of you might already be using a dashboard with different basic metrics. We can use that additional layer on top of that to calibrate it, to fine-tune it. Eric mentioned basically that in your strategy, there's a difference between analytical testing and analytics provided by ICT. Now, in my view, sometimes there's a question: what is the difference between analysis and analytics? Now, in my view, the difference is that analysis looks in the past and identifies root causes, while analytics also looks into the future. So based on a past performance, it predicts into the future. It extrapolates that to the future. And remember, you can use this to tailor your approach toward how you're going to approach the whole testing, how you're going to adjust the testing. One thing, as mentioned by Eric, is doing a risk-based approach. You might create the risk based early on based on the requirements, on the insight that you have. But guess what? Sometimes reality doesn't obey with your risk strategy or your risk analysis. So this analytics gives you this insight, this opportunity to fine-tune it based on the findings that are being reported directly from the market, from the source. In Capgemini, we call the term cognitive QA as a way of putting together an approach of collecting the data from different sources and using artificial intelligence on top of that to create this layer of optimizing your test strategy, your risk approach. How's it done? Obviously, you have multiple sources of data in your system today. You have, for example, the system where you have your requirements. Might even be the same system. You have your development, code base, your testing repository where you have all your test cases, project management tools. We have defect repository, defect reporting tools. You might also have operations where you have the support people logging into the system with remedies, your PMCs, etc. And you have data sources from user experience. Now, the idea behind cognitive QA is to extract the data from the different sources and combine it using an intelligent way. So there are 4 layers that we've used. First of all is the simple collection of the data from the different sources, which might be structured data or unstructured data. Then you have the layer of analysis, understanding, managing, understanding what the customers are using based on DI, prediction, extrapolating the past to the future, and their future behavior, and at the end, artificial intelligence on top of that. Trying to look into patterns that different users are using, or different bugs and correlation between bugs and user behavior, etc. That can give you an idea about how to tailor your approach. Now, maybe the best way to explain it is to show a video. I'm going to show a real example of how to use cognitive QA. You see if you can set it up. This is done by one of our customers in the US, and it's quite recent, so let's show you this. Can you put on the sound, please?
In organizations placed around the globe, we have over 350 plus test professionals around the world that validate the hardware and software for these products.
What got us interested in looking at cognitive QA was when I came across the World Quality Report.
We had recently moved to a test automation capability, as well as moved into a Malaysian-based tool suite.
We were kind of looking for the next big thing.
We've had a huge amount of data available, but we really didn't know how to take advantage of that and what we could actually extract from that data. And that's where cognitive QA came in.
We didn't really have a pain point identified yet when we started looking at this. We actually got some of our subject matter experts, and we really started broaching the topic with them and finding out which areas would really solve problems that were hindering them and slowing them down.
We have a lot of challenges around the complexity of the server software combinations.
Types of NIC cards, the types of RAID cards, the OSs, the browsers.
These are going into lots of different environments. And it's incumbent on us to make sure that we deliver the highest quality product to our customers at the initial release.
The possible configurations that you could come up with, it's very large, very vast, and we just quite frankly don't have that much time or money to go test all of them. So our test leads go through a process at the beginning, which is typically about a 2-week process, where they take in historical defect trends, the new requirements, weird combinations of things that they've seen in the past, trying to figure out what are the smallest number of configurations we can do that we're going to get the most coverage. With cognitive QA, what we're hoping to do is get that 2-week process down to a matter of hours.
The second area of opportunity through the cognitive QA solutions was really helping us with our test case planning to look at prior test case runs through a pass-fail frequency score. And the ones that failed less, we would want to prioritize those later into the program, and those that failed more frequently to the front end of the program. Finally, we aim to apply the analytics to determine whether we need to automate those, retire those, or even refactor those.
The cognitive QA fits in really well with our test strategy because it dovetails so nicely with what we've done in test automation and continuous testing.
Okay, I'm gonna skip to the next part. I mean, this is the part where he speaks about, how wonderful Gemini is the company, etc. So I'll skip the commercial part of it. But basically, the idea that the challenge that we're facing is that they had continuous delivery going on, continuous deployment, and testing was becoming a bottleneck in that process, and especially regression testing, because they had so many tests to be executed, and even though that many of them were automated, it was still a very lengthy process. So they wanted to be able to optimize, taking all the regression tests and squeeze it down to a manageable number. And cognitive QA analytics helped them identify a correlation that will enable them to make that reduction and optimization. Now, one of the things we discovered in the World Quality Report, and believe it or not, is that 30% of all test cases are redundant. 30%. Now, tricky thing is, of course, is identifying which 30% are redundant. And of course, the idea behind cognitive QA is that it helps you identify those 30%. So the idea is basically looking at from a risk point of view, identify what are the high-risk test cases that you should start by executing. So you can determine the priority of the execution of the test. Now, I was once at a company some years back, and I was surprised that execution of the test cases was done, believe it or not, following an alphabetical order of the test cases. Why? Guess why? Any guesses? It was actually the test repository was just being actually ordered by ascending order, using alphabetical order, which is, for me, is very surprising that you're just executing based on alphabet. This is a much more sound approach. You're basing your execution on risk. So you're selecting the highest risk first. Now, the first thing we did was at this company is identify those 30%. Actually, for this case, it was about 20%. So we took 20% and removed immediately. We said you don't need to do those test cases. These are either being covered by other test cases, or these are test cases that have no data or not validating anything, or these are test cases actually that are failing, and you either correct them or you remove them. Then we looked at basically all the test cases that needs to be executed. And here, for example, the number is about 11,000 test cases. Now, the customer wanted to reduce that because they only had a few days, but used to use weeks on. They wanted to reduce the number of days. So, okay, fine. What we can do is we can push up the handle, put the risk level to high, and reduce the number of test cases from 11,000 to 2,000. You can still achieve the highest level of coverage, but you're taking a risk. Now so my question is, who's making that decision? Is it you as a tester? Back to my initial discussion about the value of testing, I'm putting that information to the project manager, the product owner, saying, okay, we only have 3 days. I'm only going to execute 2,000 test cases out of 11,000. You're going to accept a high level of tech risk, which would be this and this. Are you okay with that? Maybe says, okay, fine. So I'm only concentrate on those high risk test cases. All right. This is basically a schematic way of how we're doing that. We're using, by the way, for the artificial intelligence, we're using IBM Watson to analyze, and in the case of Dell, we use actually 8 different cognitive rules to enable us to do the correlation between different data sources. All right. So my point is, using analytics can give you an additional level of intelligence in your PIA work. And it's also showing a shift from the existing playbook that we follow today towards a new playbook, which is all about identifying patterns, using platforms, moving more into user advocacy, and having a high level of automation. My point is, of course, this is not replacing it, but it's complementing. So activities you see on the right side of the screen are getting more and more visible and more needed to be done, while the ones on the left are gradually diminishing, but they're still there. Obviously, moving from core IT to fluid IT also means that we're transforming testing. What about culture? What about the people aspects? Sometimes I think you feel in testing that in this situation, you have a developer, you're a very creative soul. Your Scrum Master, project manager, wants to run the project using military precision. You have your product owner who also wants to drive the highest value to the customers in the shortest time, as fast as possible. You have your ops engineer who will say, I will not have any changes in my production system. How to make sure? Sometimes you feel that you're a tester and the old little guy in the middle of the whole thing. Yeah? Ever been in this situation? Now, moving into agile DevOps way of thinking promotes the idea that we're all working in one coherent style, all working towards a common goal. But guess what? Often you have different agendas, and before aligning on those agendas, it will be very difficult to make the move to the fluidized scene, move into the direction of cognitive QA. Sometimes even have management having different perceptions that will also be working with a team and have their idea. They probably read, for example, the latest report or the latest conference about agile, and see that this is a silver bullet. And sometimes just because management says that we should work as a team doesn't mean that you're really working as a team. Right? Let me show you an example. This is the
Hey guys, have you got something to tell me?
Yes, well, it's like this. Look at you,
My IT team.
yeah, team players, each and every one of you. But she has no other people who can't act in a team on my team. Excuse me.
Hello? What? Well, if you can't work as a team, you're all fired. That's it, you have been fired. Get the things and go. Hello, security. Everyone on floor 4 is fired. Stop from the premises. And do it as a team. Remember, you're a team, and if you can't act as a team, you're fired too. Go on. Get on to recruitment. Get them to look for a security team that can work as a team. They may have to escort the current security team from the building for not acting like a team. Team! Team, 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 team. I even love saying the word team. You probably think that's the picture I found. It's the 8. Oh.
Okay. This is taken from the IT crowd. Good Entertainment, by the way, is now on Netflix. So if you look it up, very good entertainment. So my point is, one thing is, of course, what the technology can bring to the table, possibilities that cognitive QA, analytics can bring to the table, but another thing is the culture in organization. Culture and management. I mean, just because your management says you want to go agile doesn't mean that you have all the preconditions going there. Typically, going agile therefore means that you have a high level of autonomous, self-governing, cross-functional teams working together towards a common goal. But if you're coming from a culture where you have a highly directive with no support kind of organization, then obviously your ability to go agile, to become cognitive, apply cognitive QA, will of course be limited. All right. So I'm just rounding up. I'm realizing that we are just we're approaching the end of my presentation. I'll have a couple of minutes left. I think this is very aligned with Eric's slide before. In my view, of course, we have two extremes. One is making your decision based on purely on data, on metrics, analytics. Another one is making your decision based on emotions, on experience. And even though that, as mentioned by Eric, we very much want to move to the left side based on data, I believe the best approach is having a good combination of both. Meaning, having a good basis of data, of analytics, but still using, of course, your intuition, your experience to guide you. So in other words, have analytics provide you the data, help you make a decision, but not make a decision for you. So with these words, I would like to conclude my session. Thank you very much for your attention.
Thank you very much, John, for that informative information on from testing to cognitive QA. Ladies and gentlemen, once again, Mr. John Forday.